Okay, so today's lesson is about prime factorization. Let's look at the first word here, prime. Prime refers to all the numbers that have only two factors. For example, how about number 2? What factors equal 2? Well, if I have, 1 times 2, that equals 2, right? But are there any other factors? No. So that means that the number 2 is prime. Let's try the number 3. What factors does 3 have? 1 times 3, any others? Nope. So it must be prime. Notice that these prime numbers have two factors, and it's always 1 and that number. Let's go to 4. Well, it's got 1 times 4, but it also has 2 times 2. So that means it's not prime. See, it's got more than just this. So we call that composite. If you're not prime, you're composite. Let's try 5. Well, 1 times 5, that's it, right? I can't think of any other factors, so it must be prime. Remember, 1 in itself. 6. Well, 1 times 6, and also 2 times 3. So it's got more than just these two factors, so it's composite. Now this goes on and on. This is pretty easy, hopefully. Now the next thing I want to let you know is that there's a couple of factors, a couple of prime numbers that people mess up all the time, and they are 9 and 15. Well, they look at it and go, oh, 9, it's odd, so it's got to be prime. No, that's not true. Every prime number is odd except for one of them, and that's the very first one, too. So let's see here. 1 times 9. Oh, and 3 times 3. So this must be composite because it has these additional factors. What about 15? Well, we always start with that. Yeah, 1 times 15. It also has 3 times 5. So that's composite as well. And just to throw you off here, but I want to show you one that most people look at that and they go, oh, that looks like it's prime. Well, guess what? It's not, believe it or not, because obviously you have 1 times 51, but you also have 3 times 17. So here's the moral of the story. Never assume a number is prime just by its looks. Well, you notice that I have the word factor up here in red. So a factor is nothing more than a number you multiply. So if I have 2 times 7, 2 is a factor and 7 is a factor. And also, while we're at it here, the answer to a multiplication problem is called a product. In this case, it would be 2 times 7 is 14. Okay, 14. You can even have factors like this. 1/2 times 0.2. They're both factors because they are multiplied. That's all it means. Okay, now let's get down to what this lesson is really about, though. This lesson is about finding prime numbers that you can multiply, prime numbers, that will equal a composite number. So if I have a composite number, let's start with 12. What are all the prime numbers that you can multiply to get 12? Well, that could be kind of tricky to figure out, but I have a way to show you. What you do is you write down the number right here that you'd like to find the prime factorization for, and you make a little tree like this. Next step, think of any two factors in the world that when multiplied will be 12, except for 1 times 12. It's the only ones we're not allowed to use, okay? Well, I can think of 2 times 6. I also think of 3 times 4. Well, I've got good news for you. You can put down either. You can put it in reverse order. For example, instead of 2 times 6, I can put 6 times 2. It just doesn't matter. I could have picked 3 times 4. It just doesn't matter. So, next step. Circle any prime numbers you have. I see we have a 2. Now, let's say you're like, oh man, I can't figure out all the prime numbers. It's going to take forever. Just remember this little tune, the alphabet song. 2, 3, 5, 7, 11, 13, 17. Well, it goes on, but if you can memorize these first, 1, 2, 3, 4, 5, 6, 2, 3, 5, 7, 11. Oh, 13. Forgot about 13. 17. There we go. So how many are there? 1, 2, 3, 4, 5, 6, 7. The first 7 prime numbers are used most often. Memorize those and you're in good shape. Okay, one more time. 2, 3, 5, 7, 11, 13, 17. All right, so we know that 2, let's come back to our problem here. 2 is prime, so we circle it. We're done with 2. Now we look at 6 and we say, hey, 6. What two numbers can I multiply to get 6? Pick any two numbers. Well, guess what? 2 times 3, that's all you get, right? Because we are not allowed to use 1 times 6. So 2 times 3 or 3 times 2, I'll do 3 times 2. All right, now, next step before we continue, circle your primes. I wonder if 3 is prime. Sure, 2, 3, 5, 7, and there's our 2. That's also prime. Guess what? We're done now. We're just ended up with prime numbers. So what we do now is we write these numbers down, like the 3, the 2, and the 2, the circled ones, the prime numbers, in order from least to greatest. So we have 1, 2, so it's gone, times another 2, that's there, and times the 3. Now watch this. When I multiply these numbers, and they're prime numbers, by the way, we've just found prime numbers, that when you multiply them, they should equal 12. Let's find out. 2 times 2 is 4. I like to go like this. And then 4 times 3 is 12. So, that is true. This is the prime factorization for the number 12. Think of it as like the ingredients. Like these are the ingredients. And when you're done, you have your food that you made, which is the 12. Now I'm not done yet. Hold on, stay with me. You have to write all prime factorization answers using exponents. So, exponents. Whenever you see two numbers are multiplied together and they're the same, you can write it a little more easily by going like this. Instead of writing 2 2's, just write 1. 2 2's. Get it? 2 2's. That's funny. I don't even know what a 2 2 is. Who cares, right? So, I've got 2 2's. Right? So, I put it up here like this. This, right here, we call it 2 squared. It means multiply 2 times. Alright, get rid of that circle there. I'm not done yet. Now I have my 3 times 3. This is the official way to write it. Notice it's in order from least to greatest. The bases are, that's called the base. You have a 2 here and a 3 here. And what else? You've written it in exponent form. So that's the first example. Let's go to another one. What if you had the prime factorization for this number? Ooh, 48. Sure. Alright, so what does it mean? Find all the numbers that you can multiply that are prime to get you 48. Start like this. And let's say you don't know your multiplication facts very well. You're like, oh, no, I can't remember what 48 is equal to. Well, just do this. Everyone knows how to split that in half. What's half of 48? Well, you know that that's 24. So just go like this. 2 times 24. All right, great. Circle your primes. I'll make mine white. Next, go into the 24. Make a little tree. Pick any two numbers that equal 24. How about 6 times 4? You could have picked anything. All right, so are either of them prime? Well, what does our song say? 2, 3, 5, 7, 11, 13, 17. Neither of them are prime, so let's go and continue. See? We can continue to do something called factoring these. All right, I circled them. Why in the world would I circle them? Here we go. 6. Well, 2 times 3, that's all we have, right? Are these prime? Sure, 2, 3, great. Let's go to the 4 now. What two numbers equal 4? Well, 2 times 2, right? Circle them because they're prime. Now, we're all done. And notice what we have here. Don't forget about this guy up here. That's a 2. Write them down in order from least to greatest. So maybe put a check mark down as you write it down. Or count up the number of 2's. I got 1, 2, 3, 4. Check them off maybe. 1, 2, 3, 4. What else do you have left? Oh, you got this 3 times 3. Now that's not your final answer, but this right here, when multiplied, should equal this. This is the ingredients for that guy right there. So let's write it in exponent form first. So we have all these repeated numbers. When you have repeated factors like this, you can write them as an exponent. So just write one of the 2's. That's it. Just one of them. And say, how many are there? 1, 2, 3, 4. 2 to the 4th power. Then you still have one more number, the 3, times 3. So let's check it now. Let's come back over to here. I'm going to write this up here. The prime factorization we found. 2 times 2 times 2 times 2 times 3. Now, I highly recommend going like this. Ready? 2 times 2 is 4. Now the 4 has to multiply then by this, that's 8. And then 8 times the 2, that's 16. And 16 times 3, well, if you're not sure what that is, you can come over here. 18, 3, 4, just come off to the side, it's 48. Hey, and that's what we're looking for, isn't it? So we know we found our answer correctly, done everything right, and here's our final answer that right there. Okay, but what if you have a really, really large number, like, let's say 540? What in the world? Well, think about this for a second. Do you see any numbers in there that look like maybe a basic math fact? Huh? Well, I see 6 times 9 is 54. That's possible. Well, let's pretend you don't know that. What could you do? Always try 2 first, because everyone can split something in half. 2 times what will give me 540? Well, think about it this way. What's close to 540? How about 500? That's close. Well, what 2 numbers when multiplied would give you 500? So you have 2 times 250, right? That's only 500. We need to get to 540. So we need to make this a little larger. Well, 2 times 270 works perfectly. But let me just show you something else here. If you happen to know your multiplication facts, go with those first. 6 times 9 equals 54. Doesn't it make sense that 60 times 9 would equal 54 with one more 0? Sure, we learned that before. So I'm going to put this down like 60 times 9. All right, let's continue on. Are there any prime numbers in there? Well, let's see. Our song says 2, 3, 5, 7, 11, 13, 17. Nope, neither of these are prime, so we have to continue. Pick any 2 factors that equal 60. Oh, I think the most obvious ones would be 6 times 10, right? And what about 9? Any 2 factors that equal 9? Sure, 3 times 3. Circle any primes. Oh, 3's a prime, 3's a prime. Neither of these 2 are primes. So let's see here. 6, what 2 numbers can you multiply? 2 times 3. We also have 10. What 2 numbers can we multiply? I can only think of just 2 and 5. Circle your primes. Well, they're all prime, aren't they? Okay, now, we're done. There's nothing else circled. We're finished. Start with the smallest prime number in here. Well, I see a 2. There's 1. There's 2. Any more? No, so we put 2 times 2. Now, what about 3's? I see a 3. Let me get a different color here. I see a 3 here. A third one. So 2 times 2, then times 3, times 3, times 3. Looks like there's 3 3's. Now, is there anything else? 2 3's. There it is, 5. So now we get to write it using exponents. Look for repeated numbers. Just write it once. Now, how many are there of them? 2. Now, the next one, put a multiplication sign. How many? Oh, boy, a lot of repeated ones. 3 of them there. So instead of writing all 3, write one of them down and say, hey, multiply them 3 times. Anything else? Sure, you got the times 5 here. And that is your answer, my friends. Here's how you say it. 2 squared. Squared is to the second power right there. And then we have 3 cubed. Cubed. 3 to the third power. Get it? All right. Well, I hope this review of prime factorization of numbers helped a bunch. And remember, you're just trying to find the ingredients to make 50. You want to find all the ingredients, and the ingredients happen to be prime numbers. Make a tree, circle your primes, write them down, and then make sure you write them with exponents. It's that easy. See ya!